The purpose and application of flow control valves in cooling heat exchanger systems on board our rigs are often misunderstood, especially the ones related to the EMD engines and Elmagco eddy current brakes. As a result of this misunderstanding, the life of flow control valves and heat exchangers is being reduced. In this program, we're going to talk about the problem we have with heat exchangers and how to help increase service life. Heat exchangers, like the radiator in your car, are made of a core of copper tubes. These tubes are normally not designed for high pressure and high volume flow. They're designed to operate at a particular volume of water and flow rate. If too little volume and too low a flow rate is used, heat will accumulate on the heat supply side. Heat dissipation is impaired. Most heat exchanger systems are subjected to an oversupply of cooling fluids to the core. In fact, it's common on most of our rigs to have pumping capacity several times greater than the required optimum volume and flow rate. This can create problems, forcing too high of a volume through the core and/or shell with an increased high velocity of fluids, which will erode the core. It doesn't take long for this state of erosion to cause leaks, and then a replacement of these expensive cores or a complete heat exchanger is necessary. Usually, what is done is to place an adjustable globe valve in the supply and/or discharge line to help reduce the volume of supply fluids to the system. The problem with using a valve is to properly regulate pressures and flow rate. Unless you've got a flow meter and pressure gauge, you'll have a hard time balancing the volume and adjusting the flow rate to exactly what it should be. And remember, too little volume and flow rate will cause inefficient heat removal, and too much will reduce core life. Even if you were to get it balanced perfectly, an accumulation of debris in the strainer or a pressure fluctuation would change your volume, so you can see the problem we have. Several years ago, we began to install flow control valves in the lines of our heat exchangers and cooling systems to balance the volume of fluid and create a desired constant flow. These devices have a self-adjusting orifice. Water volume or pressure differential controls are spring-loaded piston-type affairs to restrict the amount of flow passing through the device. The volume is determined by the size of the holes in this piston. From the supply side, the more force behind the water, the more the piston is pushed upward, and the more the flow is restricted. When the force recedes, the spring pushes the piston open again, which lets the water flow with less restriction, creating a constant flow rate. The system is designed so that there are no adjustments. The flow control cartridge is calibrated at the factory, so you have to order the correct cartridge for the job it's going to do. The cartridge fits into a body, and the body comes in several styles. How do you select the valve for your application? Simple. Choose the material of valve construction you need, stainless or Monel, and the differential pressure range. Then use the Griswold valve selection chart to pick the factory-set GPM flow rate that meets your requirement. The flow rate will determine the valve size. If the size is different from your system, standard adapters can be used to make the connection. Here's the one we use most often on our rigs. Now, some of you may have not known what the flow controllers were used for. In more than one case, these flow controllers have been removed from the system. Since most people don't understand the flow controllers, they believe that they're not working or find them completely destroyed due to improper selection. For instance, freshwater valves used on a saltwater application. Actually, there are several things that could go wrong with the valves. First is that an improperly sized cartridge has been installed. Naturally, this could restrict or increase the flow more than you would want. The other problem that can occur is the wrong type of cartridge being installed. There are two types. There is a stainless steel cartridge installed in cast iron bodies that are used in freshwater systems. Then there are Monel cartridges installed in naval bronze bodies that are designed for use in saltwater environments. Naturally, a stainless steel cartridge will corrode after a few weeks of use in salt water. The Monel will last indefinitely. Functionally, the valve should operate without problems. According to the manufacturer, they should not stick and should not get plugged. The problems you might run into with these valves might be incorrect selection, application, or installation. Each valve is preset and tested at the factory and will automatically limit the rate of flow to required engineering capacity within a plus or minus 5% accuracy over an operating pressure differential of at least 14 times the minimum required for the control. The control mechanism of the valve consists of a self-contained open chamber cartridge assembly with unobstructed flow passage that eliminates accumulation of particles and debris. All internal working parts are stainless steel when working in freshwater or Monel for application in seawater. The cartridge assembly consists of a spring-loaded cup. The cup is guided at 2 points and utilizes the full available differential pressure across the valve to activate the cup and thereby reduce friction and eliminate binding. It has a thin orifice plate for self-cleaning of the variable inlet ports over the full control range. Each automatic flow control valve kit consists of a 1/4 inch by 2 inch minimum size nipple. Also, the manufacturer provides a metal identification tag with chain for each valve. The tag is metal, stamped with zone indications, valve model numbers, rate of flow, GPM, and differential pressure ranges. Flow measuring instruments are also furnished by the manufacturer. These are to verify and check the flow rates. The correct flow is verified by establishing that the operating pressure differential across the valve tappings is within the range indicated on the identification tag. The pressure measuring apparatus is portable and consists of a pressure gauge with a 4.5 inch diameter dial, instructions, hoses and connections, and a push-button 3-way valve which transmits either of 2 pressures to the pressure gauge. A carrying case is also provided. The meter kit and hose model number, by the way, is 3429. That's the only one we want to use on our systems. How do you install these flow control valves into your system? Well, there's really no special installation technique required to do this job. You see, the water flow direction is marked on the valve, and the piston should face the supply side of that line. If it's installed backwards, it won't control the flow. Be sure to clean the lines upstream of the valve of particles larger than approximately 1/16 of an inch in diameter, which is equivalent to a 20 mesh strainer. This will ensure that the valve won't clog once you start putting a flow through it. And finally, be sure to seal the threaded-in valves with approved pipe compound. Be sure when you use the smaller valves not to torque them down in excess of 75 foot-pounds, because you could damage them. If you've ordered a valve which is the flange-mounted type, be sure and use the studs that are provided by Griswold. They're tested to the proper specifications required for those particular valves. That's really all there is to the installation procedures. They're very simple to install, and as we've already mentioned, there's really not much to do once they're installed maintenance-wise, because the valves are factory assembled and tested, and you really shouldn't have any reason to tamper with the valves once they're installed. And those valves that are furnished with pressure fittings may be checked with suitable gauges, as we've mentioned earlier. If you find that they're not operating to the specific range selected, refer to the conversion table to determine the proper flow rate and pressure range needed for that particular system. Now you know what the Griswold control valves are, what they're used for, how they're maintained, and how they're installed. If you need any further information on the Griswold control valves, be sure and contact the manufacturer or contact the Dallas Office Equipment Management for any help.